Hi, welcome to ARISTOTHINK. Today we're going to discuss about trapezoids or trapezium. Trapezoids is the term they use at United States and Canada, and trapezium how they define this polygon in UK. So I'm going to use the term trapezium. They mean the same thing, but that is when I'm going to use it. Well, and this is the basic trapezium, where we have, how do you call? First, let's give names. So we call this one the shorter base. The shorter base. We call this one the longer base, and we call those guys legs. This is one leg. This is the other leg. And I'm not going to write in here, but that is a diagonal, okay? Those are the diagonals, two diagonals. Now, what about trapezium? Well, we have some types of trapezium. I'm going to write very briefly here. So we first have this very perfect, let's even use those parts in here. You see, we have this very perfect trapezium where this side is the same as this one, and we're going to call this one the isosceles trapezium. Then we can have something a little bit different. You see, one leg, the base. Now this leg, I'm going to make it more extensive, can you see? The other one was like this, and this one is going to be more extensive, something like this. And because this has one length and this has a different length, I'm going to call this one the scalene, just like the triangle. The scalene trapezium, right? Trapezium. Well, we can also have a third type, which is the right trapezium. Well, if you figure out that the right comes from the right triangle, the 90 degrees, you are correct. So here comes our trapezium, then something like this, then the right angle comes here. So we do have a 90-degree angle in here, right? And this we're going to call the right trapezium. Oops, the Z. Well, we can also have the acute one. The acute is when you have, I'm not going to draw it, is when you have that angle and that angle being acute, and we also have the obtuse. The obtuse is when you have something like this. It's a little bit weird. Okay. Why obtuse? Because this angle is greater than 9 degrees. Well, and what makes a trapezium? A trapezium is defined because we have that base and that base, they are parallel. That is what makes a trapezium, okay? Now, some people define a trapezium as having at least one parallel pair of bases, and some people say that a trapezium can only have one pair of bases. So it depends on the definition. A trapezium might be also a parallelogram. Depends. I'm not going to go into this detail because I don't want to analyze the geometry part of it. I just want to go into the algebraic part of the mathematics in here. So I'm going to discuss about areas. That is, if you're interested about knowing areas, I'm going to give the ratio between diagonals, bases, and so on. So if you want to know how to find those areas in here, so this is the video for you. If you're not, you can listen either way. You're going to learn something. You are always learning something, but that is what I'm going to teach you today. So first, let's give names. Okay, we have to give, I'm going to call this A, B, C, then I'm going to call it this one D, E, F. Just 1 second. Okay, I had to turn something off, I'm sorry. Now, let's give names of everything, and the first thing that I have to teach you I'm going to call it as 1. Let me move this a little bit up. Something like this, and then I erase this. Okay. So this is the first part, because I don't know if you know my videos. I hope you do. If you are following me, if you are not following me, please subscribe to my channel, because I don't have much time to make videos, but as soon as I can make a video, I'm going to make one and put in here. And because I have also to edit the videos, I don't have time for that. Sometimes I just make the video and I just go at the waiting list so I can edit them. But please subscribe to the channel, help the channel to grow, because I have huge ideas for this channel. I wanted to make very big, but you gotta help me too. I cannot make it big alone. So subscribe to the channel, please, if you haven't done so. Now, first part I want to show you, we're going to talk about ratios actually. Ratios. What about ratios? Well, we're going to talk ratios. When you have all those lines in here, those segments, let's call segments, and first let's put this is A, B, C, D, and let's put an E at the center. I'm going to use the E in here. Okay, it's going to be this one. Now, something that we have to talk about geometry. When you're talking about points, we also use a capital letter like this. And when we are talking about segments or lines, wherever, we use the small letter. Okay, those are for lines, and when we have vertices or points, whatever, we are going to use capital letter. Okay, so we just have to define. And what about angles? We use Greek letters. Greek letters, like this is alpha. This is alpha because they are vertical angles, right? They are the same. This is going to be a capital because it's a point, and this must be a small letter because it's a line, a segment, whatever. That's how we define things. So this is our trapezium. And now, if you come to think about it, we have this ratio here. So we're going to say that the shorter base divided by the longer base, that ratio is the same ratio when we divide B by E, those parts of this diagonal. Can you see? And the same goes when we do the other diagonal, C to D. And this is crucial if we want to understand about the area relationship. And that's what we're going to discuss here. So this is the first thing I need to tell you. You gotta know that ratio, but it must be completely automatic to you. Just like you know your name, your parents' name, your brother, your sister's name, you gotta be like this. When I tell you A and F, you have to see that A and F have the same ratio as B and E and C and D. Okay, this is the first thing you have to focus. Now, I'm going to tell you 3 things before we start. Before we start analyzing the area ratio. Now let's talk about area. Okay, so for that I'm going to draw a triangle. I'm not going to be very worried about draw a perfect triangle in here, but let me try to make something nicer. Let's make this triangle in here. Okay, something like this. Yes, okay, it can be, but you see, the reason I didn't want to draw a triangle like this because I want to draw a very different triangle. So you must give me some time. I'll have to draw by hand. So imagine this triangle. Another one. I don't want to draw an isosceles. I want to draw a completely weird scalene triangle. Of course, that's not going to work. Let me force this one here. And then the last part of the triangle. Good. So this is a scalene, right? Why? Because how can you say that? Well, because this is one length, this is a different length, and a different length. Now, but I'm not going to discuss about that. Well, let's have this triangle. And now, I'm going to divide this triangle into 2 triangles. Okay, let's call it this part A and this part B. Now, what can we say about the area of those two triangles? So let's go first here. I'm going to color this one green. So this is going to be the green triangle. Okay, now what can we say about the green triangle? Let's try to describe its area. The area 1, this is going to be A1. Okay, the area 1 is going to be what? The base times the height divided by 2. Okay, and well, yes, that would be the height of that triangle. And remembering, what is the height? The height, it is the line that you connect from the vertex perpendicular to the base. If that is a base, so that is going to be the height. So this is area 1. And what can we say about the other area? Let's like this. So this is going to be our second triangle. Like this. Okay, I think you got the idea. So this is going to be the triangle number 2. So this is area 2. So area 2 is going to be what? Is going to be A times the height divided by 2. But now something interesting. You have to realize that these parts, for both of them, are the same. So this is going to be a constant. Okay, and this is also going to be a constant as well, and they are going to be the same. Why? Because they share the same height. Okay, so I can safely say that when I'm dealing with this area A2, so because of that, I can say that the area 2 is direct proportional to the side A. And I can also say that when I'm talking about area 1, is direct proportional to the side B, to the base B, right? Base B, and this is base A. What it means is, if I double B, I double the area. If I double A, I double this area. Whatever I do to the base, I make the same change to its area. And that's going to have huge consequences when you're dealing with the trapezium. Let me see, what else do I have to tell you this? Okay, and let me just a brief example. So let's say that this area, this A is x, and B is going to be 2x. Well, if this length is twice this length, that means that area 2 is going to be twice area 1, just because of that. Okay, so that is what it means. Okay, what happens if this length is 10 and this length is 5? If this length is 5, this length is 10, it means that it's going to have twice the area of this one. If this is 3 and A is 1, this area is going to be 3 times as bigger as this one. That is what it means. So hold that on your minds. And now I need to tell you another thing about area. Yes. Now, what can we say about area? Well, I'm going to draw another triangle, but this one is going to be a simple one. Let's see this triangle here. It's faster if I draw it like this. It has an angle and 2 sides, A and B. Now, do you know how to tell the area of a triangle when you are given 2 sides and 1 angle? So the area of this triangle here, it's going to be side times the other side times the sine that connects those 2 sides. So sine of alpha, and divide everything by 2. So that is the other formula that I need to tell you. And let's suppose that you forget. No, is it sine? I don't know, is it cosine? Sometimes you might get some troubles, and you might lose the formula. So if you want to find this formula back, just think about a square. Think about a square. It's very easy. And we are going to calculate the area of this triangle in here. Okay? And as you know, this triangle is 9 degrees, L and L. And what is the area of this triangle using this formula here? Well, it's going to be A times B times the sine of 9 degrees divided by 2. As you know, sine of 90 is 1, right? This is 1. So in the end, this area is going to be L times L divided by 2. Could it be cosine? Could it be cosine in here? No, because cosine of 90 is 0. So just whenever you lose a formula, try to make a very simple shape, and chances are you're going to get that formula back to your mind. So you have to find those, okay, to begin the discussion about areas and trapeziums. We have to know that this ratio exists. Then we have to know how to relate areas when you think about the same heights but different bases in here. And then we have to know how to calculate areas only depending on 2 sides and 1 angle. Okay, now we are ready, and now this discussion begins. Okay, now we're going to discuss about the actual trapezium, and for that I'm going to ask you a second. So I'm going to bring my trapezium here. Is it here? Yes, it is in here. So let's just go here. Let me copy that trapezium because it's ready. Copy. Yes, copy it. Good. Now let's just paste it. Good. Wonderful. So I'm going to give you 4 examples. This is example number 1. And so our first example, let me just erase everything. We don't need those points in here. I want to make as simple as possible. Now, for this example, I'm going to give you this area. And it's going to be 9. Yes, what else am I going to give you? Okay, I must give you something else. I must give you the ratio somehow. Or maybe this area and this area, or this area and this area, but I must give you something. Or maybe the ratio between those diagonals in here, those parts of the diagonals. But in this case, I'm going to give you a simple ratio. This shorter base is 1, and the longer base is going to be 3. Okay, now let's start. So when I give you this, so this is given to you. And what is the problem? Given the shorter base 1, the longer base 3, and that area 9, tell me the whole area of this trapezium. That is the question. So how can you find the other areas? Well, you're going to see that it's pretty easy, okay? Now, first we have to acknowledge that the ratio, it is 1 to 3. Remember this part in here? Ratio between A and F. Oh, this is F. I'm sorry, I put B. Oh, I'm sorry. Of course, it's A to F. Now, is B to E and C to D. I'm sorry, because sometimes I put B in here. So, the ratio between A and F, then B to E and C to D. Okay? So, we first have this ratio. So, the ratio is given to us indirectly, so it is 1/3. So if 1/3, I can say that if this is x, this is going to be 3x. Agree? And because I'm telling you it is an isosceles trapezium, okay, I can safely say that this diagonal is also going to be x, and this one is going to be 3x. Okay, so ratio 1 to 3, 1 to 3, 1 to 3, and x because it's isosceles. Now, let's now use a property of this area. You see, I'm going to use this area. Base, height is the area. Now I want you to think about this triangle in here. Think about this one. Now tell me, this base is 3 times as big as this one. It means that this area is going to be 3 times bigger than this one. Oh, it doesn't seem so. Yeah, because this is no way that this is 1 and this is 3. Of course, that is why. Don't try to make sense of this shape, because I'm just drawing an ordinary any kind of shape. So no way this is 1, this is 3. Agreed. If this is 1, this is not even 2, 1.5. So that is why it doesn't seem like that this area is 3 times this one. But algebraically, please think about the numbers itself. So if this is 3x and this is x, clearly we can safely say that this area is going to be 3, right? A third of that. Okay, now, because it's an isosceles, I can also say that this area is 9. Why? Because this area must be the same as this one. Not because it is an isosceles. We are always going to have that. We're going to see later. So 9, 9. And what about this area in here? How can we solve it? Well, we can solve it in 2 ways. One way is to solve like this. Now, and for that, I need you to think about, think about the yellow triangle. Can you see I'm making something yellowish in here? Think about this triangle in here. Okay? Good. Now, this is 9, and God knows what is that. But now, think about this. What is the base of this triangle? Can you see? What is the base of this triangle? It is x. What about this other triangle? You see, try to see those triangles. I don't know if you can see it. Try to see now that triangle. This one. This triangle has base 3x. Agree? And now try to see maybe a red one. Yeah, let's see. And now try to see this other triangle here. It has base x. So if you look through those lenses, you're going to realize that if this base is triple as this one, this is 9, the area, so that area is going to be the triple. So it's going to be 27. Agree? Okay, we got all the areas. So the whole area is going to be what? 30, right? 30 plus 18, 48. So the whole area, the area is going to be what? 30, 48, right? So 48. So this is one way to solve it. Now I'm going to give you another example. I lost my pen. I hope it is this one. Okay, so yes, this one. Now I'm going to give you a different way to see it. How can you? Let me see now. I'm going to use the same. Let's copy paste. Good. You can just fast forward if you want to. Okay. I just need to draw those in here, and unfortunately I cannot edit that video because I really wanted to throw it today at my channel. So unfortunately I really can't edit, so it gotta be like this. I'm going to please ask you for your apology because that is the only way I can do it today. So let me give you another situation, and on that situation I'm going to change. I'm going to tell you that this area is 14 and this area is 16, and again I want you to tell me the whole area. How can you do it? Well, we have to find ratios. You gotta find the ratio first. Okay, so initially what can you do about it? Well, if we know the, let me put it here, if we know that those two areas is 1 to 4, it means that, look, if the area, we can relate area with its base. You see, the area is proportional to base, and that area is proportional to that base considering the height is the same. So that is what we're going to use here. So because this area, it is 4 times bigger than this one, we can say that this could be x and that could be 4x. You see? Think about this triangle here. Okay? So actually divide, right? This is one triangle and this is the other triangle. You see? So we can safely say that. Let me erase this one. So this is x, this is 4x. Good. We are starting to see things. Now, what can we say about that part in here? Is it going to be x? Not necessarily, because nobody said that this is going to be an isosceles. It could be scalene. So we can say y. So if this is y, I can safely say that this is 4y. How can I say that? Well, because the ratio of the shorter to the longer base, that segment to that segment, and that segment to that segment is always going to be 1/4. The ratio here, it's always 1/4. Okay? Now, okay, and how can you solve this area in here? I'm going to solve a little bit different than I did in here, because if I follow the same pattern I used up here, what would be that area in here? Well, think about this triangle, the yellow one, and now think about the blue one. Okay? If you think about those, we can clearly say that if this triangle has base 4, this triangle, the blue one, has base y, and the height, no need to draw the height, okay, please, no need. But the height is the same for both of them. So because this triangle has a 4 times bigger base than this one, well, clearly that triangle is going to have an area 4 times smaller. Base 4 times smaller, the area 4 times smaller. Wonderful. So, and we just have to learn about this other area here. And how on earth are we going to? Because if someone have said to us that this would be an isosceles, this clearly would be 4. So how can we do it? You're going to see it's going to be 4 as well. And even being an scalene is going to be 4. You see, those two, they are always going to be the same area. But let me tell you something first. How can you solve it using that formula? Now we're going to use this formula here. See, area is side sine of the angle. Okay, now for that, let me see what I'm going to do. Okay, so now I'm going to erase that, and I'm going to put, let's analyze those 2 triangles in here. Okay, good. Let's paint a little bit more. I think it's enough. Now, I need you to look at this. We're going to need that angle and alpha, and also that angle alpha. And they are the same because they are opposite to each other. And now we say they are vertical angles, right? What is vertical angles? Well, is when they are opposite like this, and because of that they are the same. Now, let's draw area 1. And for area 1, I'm going to write like this. So this is going to be area 1, which is 4. Okay, but so area 1, it's going to be 4. And but how can we get area 1? Well, it's x times 4y. Agree? One side times the other side times the sine of the angle between them, sine of alpha divided by 2. Now, what is area 2? Here, what is area 2? Area 2 is going to be what? Let me put lower. Area 2 is going to be the same, not the same, but the same process, y, okay, times 4x, agree? Times the sine of alpha again divided by 2. Now let me rearrange this one. This is the same as 4. Oh, no need to rearrange, but can you see that they are the same here? They are pretty much identical. So can you see? They are the same thing. Okay, so with those in mind, I can safely say that A1 equals A2, even though this could be one length and this could be different. They don't need to be the same. So clearly everything is equals to 4. So this is a 4 as well. Okay, so what is the area? So it is a 4 plus 16 plus 1. This makes 20, 25, right? 20, 25. So is there anything? Let me see. Yes, there are 2 more that I want to discuss with you. And this one is going to be the 3rd one. So, but they just kind of keep repeating. But please don't hang up. Stay there, because the more you see, the easier it gets for you to retrieve. Like I always say on my videos, to store things in our memory is pretty easy, but to restore it afterwards, that is the thing that some people say it's very easy, but it's not easy. To restore things from our memory, that can be something pretty tricky. Now, okay, let's go to the 3rd part. Let's separate a little bit more. Okay, I'm going to remove that. Let's make things better. Good. Now I'm going to erase all of that. We don't need these anymore. I'm going to give something different. Now I'm going to give you the ratio between those guys in here. And the ratio is going to be like, okay, so I'm giving you that this is x and this is going to be 3x. Okay, now if I tell you that this x is 3x, I'm giving you right away the ratio. So the ratio is going to be 1/3. Agree? This is a ratio. If you don't know, this is x over 3x. The x cancel, and this is just 1/3. So the ratio, it is 1/3. But of course, I must also give you something else. I must give you at least one area, and let's suppose that I give you this area. So this is given, okay? So I give you the ratio between the parts of this diagonal, and I give you one area, and you have to find everything else. Now, what can we say about this area? Let's see. Well, first we could think about this triangle in here. That would be the first thing I would do it. You see? And we can think about this triangle, the blue, and we can say something about this other triangle in here. We can clearly see that this triangle in here, oh, I just hope my picture doesn't touch anything, because sometimes you can see things under my picture, okay? But anyway, so if this is 18 and we know that this base is 3 times bigger than that, it means that that area is going to be 3 times smaller as well. So this is going to be area 6, right? Because 6 is 1/3 of 18. Now, what else can you say it? Well, if this is x, this is 1/3, so this is going to be y, and this is going to be 3y, right? Now, what else can we do it? Now, I'm going to erase. I'm going to erase that, and now think about this other triangle in here. The same process, but now change your focus now. Now, instead of thinking about those two, think about those two in here. Now let's give it green. Now look at the green triangle. Look at the green triangle and the orange one. Well, look at their bases. This base is 3y. This base is y. So if this is 18, again, this should be 1/3 of that, right? If the base is 1/3 of that, that area is 1/3 of that. So this is also 6. Again, they are always going to be the same, okay? And then even if you look through that formula in here, okay, side angle, sine of angle, you can also see that, you see, what is the ratio that is being multiplied? X times 3y, so it's 3xy, and here the same 3xy. The sine of the angle is the same, so the ratio and the sine of the angle is the same, and the other multipliers x and 3y are also the same. So again, the area is going to be the same. Now what about this one? Haha. Well, we can do on the same way as well, but let me tell you something a little bit different. What is the ratio? 1 to 3, agree? So let me give you this. So it's just like if this is like, I don't know, m, and this is going to be 3m. Okay, now let me tell you a secret. Not a secret, you can also develop this through the formulas, but there is also something that it's very interesting to remind. It's like a pocket tool that you should have with you. Now look at that, and now imagine this triangle in here, and imagine this other triangle in here. Their areas is pretty much straightforward once you have the ratio. Is the ratio squared? You are going to see later this. Now, if the ratio it is 1 to 3, okay, so the ratio is going to be 1 to 9. Okay, so the area ratio, let me write in here, because the ratio is between that and that, okay, those two. So the area ratio is going to be the ratio squared. Okay, which ratio? This ratio is squared. So the area ratio in this case is going to be 1/3 squared, which is going to be 1/9. You see? So whenever you have the ratio, if we square that ratio, you get the ratio between those areas in here, the green and the blue. So what is the ratio? 1/3. You square that, 1/9. So if this is 18, that area should be 9 times smaller. So it's going to be a 2. Only thinking about this. But you can also see through the basic area triangle. You see, look at this triangle, has area 6 and base 3. This other triangle has base 1, 3 to 1, area 3 to 1, 1/3 of that area. So can you see, there are many ways we can solve it, but I'm going to explain you why the area ratio between those two is a ratio squared. And for that, let me give you, let me see, yeah, I'm not going to give another example. Let me just go through here. Let me just copy this one. Yes. So this is going to be number 4. And on number 4, I'm going to study this. Okay. Now, well, I'm giving you that, let's suppose that this is 1 and this is 3. Therefore, this is going to be x, this is going to be 3x, and this is going to be y, and this is going to be 3y. Other than that, I'm going to tell that this is alpha, this is also alpha, because they are vertical angles. No, nothing there. And now I'm going to ask you to focus your attention on this particular triangle, and then on this particular triangle in here. Okay, it's better. Now, let's go with this triangle in here, okay, area 1. So the blue area is going to be what? Side times the sine of alpha divided by 2. What about the purple one? What about the purple area? Okay, this one. This area is going to be what? Sides times sides, oops, right? Those are the sides. And now the angle times sine of alpha divided by 2. Let's develop a little bit more. This is going to be 9xy sine alpha divided by 2. Okay, so can you see what's going on here? What is this? This is nothing else than A1, isn't it? So I can safely tell you that this is going to be 9A1. So you see, A2 is 9A1. And why is that? Well, it's now if I just develop a little bit further, so A1 divided by A2 is going to be 1/90. Can you see? And that is what I told you. And this is nothing else than 1/3 squared. That is why, because look, now without formulas, sometimes we think about formulas and we get lost. Now just consider this. The area of a triangle is side sine of angle. Now the sine of the angle is the same because the angle is the same. But now look at that multiplication here, x and y. So we just have x and y in here, and in here we have 3y and 3x. So we have a 9, you see? Is 1 to 9. And why the ratio is squared? Because whatever goes in here, okay, thirds, that third also goes in here, with the ratio on this diagonal is the same ratio as this diagonal. So that is why the ratio is squared, because for each part, for each leg of this triangle, we have to multiply again by the other leg, but the other leg has the same ratio. That is why the ratio is squared. But if you don't remember that, don't you worry. Understand that this area and this area are related just by this the ratio squared. And just to close, this is the last example, and then we close the video. Now this is the last example, and this example is going to cover exactly what I just told you here. And if you survive it by now, with all those minutes, I guess you can do almost any kind of problem about trapeziums. Now I'm going to tell you this. Yes, I'm going to tell you that this area is 100 and this area, no, this area is 100. And I'm going to tell you that this is 7 and this is 21. Only that. Well, if I straight on, what is the ratio? The ratio, it is 7/21, which is a fourth. No. It is this, I'm sorry, not 7/21. Oh my gosh. No. The ratio is, this is going to be 2 and a 10. Is that so? Yes, 2 and a 10, I'm sorry. It's 2 and 10 and this area is 100. Okay? Now, what is the ratio? The ratio is 2/10, which is 1/5, right? Now, if we square 1/5, we get 1/25. And now we know that the ratio between this triangle and this triangle should be 25, right? 1/25. So if this is 25, this one clearly is going to be what? 100 divided by 25, which is 4. Okay? So this is 4. Remember, the ratio between that triangle and that is the squared of this ratio. So this is 4. Now, what is the ratio 1 to 5? Great. So if this is x, so this should be 5x. Okay. So if this area here is 4 with a base x, therefore if we multiply this base by 5, what happens to the area? The area is multiplied by 5 as well. So this is going to be 4 times 5, which is going to be 20. Agree? Well, 20, and this one is also 20. It's always the same, but if you wanna go for it, please, this would be y, and again this is going to be 5y, right? Okay, you can also think like this triangle here. Let's change a little bit. We have 100 area with base 5. If now I divide the base by 5, a fifth of this base, the area should be a fifth as well. So you see, that is what I want to discuss with you. It's very simple. There is nothing much that you can go over it. That is everything I believe I can teach you about trapezium. I'm sorry if the video is extensive, but at least everything you need to find is in here. So thank you very much. I hope you have enjoyed. My videos are not short. That is not the idea of my videos, because if you want short videos, you have plenty at the internet. The idea of creating such videos is that if you don't want to hear anything else about that topic, just fast forward. But if you need to go into more details, then my videos are perfect for those students that think that they understood but they didn't. So that is why I intend to make the videos as detailed as possible. So thank you very much, and I see you next time. Bye bye.